Welcome to the eBeam Initiative virtual reception. I'm sorry it's virtual this year again, but let's have fun for the next hour, talking about the business and technology of mask making. And I'm Aki Fujimura, I'm founder and CEO of D2S, which is the managing company sponsor of the eBeam Initiative. So I first want to say thank you, a big thank you to the organizers of the two conferences here. I am presenting at the Baka side of the conference twice this year. One is in a deep learning session, in general, talking about a formula for success for deep learning in the semiconductor manufacturing industry. And then I'm also talking in a curvilinear mask session. It's incredible that we have an entire session on curvilinear masks, but I'm also going to be talking about a general set of topics on curvilinear masks. We do not have the mask maker survey results to publish this year because mostly due to COVID, we just didn't have enough participants. So we are missing that presentation from this year's conference. So let's talk about the eBeam initiative itself. It is an industry consortium made up of these people, and we try to have a balance of the whole ecostructure around the art of mask making and the art and business of mask making, I should say. And it's been a lot of interesting discussions in this forum too. We've been doing the Luminary surveys now for 10 years. So, 10th anniversary, congratulations to everybody. And thank you so much to everybody. Of course, we cannot have a Luminary survey without the Luminaries helping us collect the data. So thank you very much to everybody for that. So let's get into today's agenda. We will first have Jan Willis present the Luminary survey from this year, and then we will follow that with a expert panel to provide color commentary to the survey results. It's Luminaries of Luminaries again this year. We have Tom Cecil from Synopsys. He is the principal engineer there. He has been famous for quite a long time as the world's leader really in IoT and particularly curvilinear IoT technology. In fact, he gave one of the best talks that we ever had in this forum a few years ago, on the very subject of IoT and curvilinear IoT, and even including his prediction that curvilinear IoT will be useful for EUV masks as well. So look forward to hearing from him. Mikael Wahlsten, who is the head of pattern generation strategy and development at Mycronic, company in Sweden that manufactures laser-based mask-making machinery, and he has led the flat panel display mask business, as well as the recent re-entry into the semiconductor photomask making in the mid-range, targeting 130 nanometer, 90 nanometer, those kinds of ground rules. So we look forward to hearing from Mikael. He also has personally been leading a lot of the deep learning efforts at Mycronic, so look forward to hearing from him on that subject matter as well. Chris Progler is the Executive Vice President and CTO of Photronics. Photronics is a public company, and as a public company CTO of a merchant mask maker, Chris knows not only the technology of mask making very well, he also knows the the business of mask making very well. So he can help us give color commentary on the business side of the set of luminary survey questions that we have. So yeah, so we look forward to the next hour. Let's start with Jan talking about the survey results from this year. Jan?
Hello and welcome. I'm Jan Willis, co-founder of the eBeam initiative, and you're about to hear the results of our 10th annual Luminary survey. First of all, big thank you to the 81 luminaries across 44 different companies who took the survey in July of 2021. And also a big thank you to all of you who have helped us over the past decade to make the survey possible. So what you're seeing in the chart is the participation in this year's survey, with the green indicating the mask segment and the purple indicating the equipment segment. And together they represent about 2/3 of the participants, which is consistent over the past decade. Now let me say a few words before we dive into the details. First of all, these are opinions. They're the opinions of the luminaries, and we invite luminaries because we think that increases the credibility of the result. Now, I'll just be your reporter today, walking you through the results and helping you understand the charts. We'll have a panel of experts discuss and share their perspective on the survey following. And then finally, you'll find the survey results and the videos available on eBeam. Okay, so let's get started. In our first result, you'll see in the chart at the bottom right that 72% this year say that 2021 mask revenues will increase. And that contrasts to only 33% who were that positive last year and predicted an increase for the 2020 revenues. Well, in fact, according to SEMI's annual Photomask report, the revenues in 2020 were $4.4 billion compared to the revenues in 2019 of $4.1 billion. Now let's keep on this topic of mask revenues and another repeat question from last year. In the bottom right, you see that 74% this year say that EUV will have a positive contribution to 2021 mask revenues. And that contrasts to 66% who said the same thing last year for the 2020 mask revenues. Now let's stay on the topic of EUV and look at some of the infrastructure questions. So in this repeat question, we found at the bottom in gold that 75% say EUV pellicles for high volume manufacturing will be in use by the year 2023. Now, as we contrast that to the 2020 result, we've actually had to cut the chart so that we can align the answers. And what you see quickly is that the 2-year trend is converging on the year of 2023. Now, in another positive response about the infrastructure for EUV, we find that 72% agree with this first statement you see in the first line of the chart, that actinic inspection will be used in the mask shop for EUV high volume manufacturing by 2023. And the way to read that first bar is that the blue and the green represent agreement, the orange and the red, as you see later, represents disagreement. In the second statement, we find that 42% agree with eBeam multi-beam inspection will be used in the mask shop for EUV high volume by 2023. And both of these results are very similar to the result we got in last year's question. Now, this year we split the third statement into two, so we won't contrast them to last year's result. But in this third statement, we made it more general to say any inspection of wafers will be used for the purpose of mask inspection for EUV high volume manufacturing by 2023. And we found that 60% agree with that statement, whereas 37% agree with the specific statement that eBeam multi-beam inspection of wafers will be used for the purpose of mask inspection for EUV high volume by 2023. Now let's turn to one more EUV infrastructure question. In this question, we see the luminaries are a little bit more pessimistic this year. Looking at the bottom of the chart circled, we see that 23% say that EUV turnaround time will be much longer than 193 turnaround time today, versus 10% who said that last year. Now, when we look at the combination of those who said longer and much longer this year, we find 74%, and that was a similar result to last year. Now, it's not a surprise then to see that EUV tops the reasons for buying multi-beam mask writers. So EUV precision on the far left is ranked as the #1 reason this year. And the way to read this chart is that we have 6 different boxes representing the 6 different reasons. And the rankings, the plot of the rankings are inside of each box, with 1 being the #1 reason. And then the dark blue shading represents the average response in the height of the chart from last year's result. And what you can see is that the #1 and #2 reasons on the far left have actually reversed order. So again, this year, more precision for EUV is #1, more throughput for EUV is #2. Similarly, the #3 and 4 reasons swap places. This year, #3 is curvilinear ILT for EUV, whereas last year, the curvilinear ILT for 193i was 3rd, and it's now 4th. And then finally, the 5th and 6th reasons remain the same and are very similar in ranking. More precision for 193i and more throughput for 193i mask. Still on the topic of mask writers, we see that in the chart on the right, purchasing sentiment has risen this year for laser and VSB writers. So what you're seeing in that chart is the gold represents the 2021 results and the blue, the 2020 survey result. And so in the far left there, you see that 38% said that purchasing would increase over the next 3 years for laser mask writers versus 32% who thought that last year. And then the specific responses to this year's questions are in the chart on the left, where green represents a statement of increase, blue stay about the same, and red decrease. So let me point you to the response for multi-beam mask writers, where the prediction remains extremely high at 90% that purchases will increase over the next 3 years. Now, on a different note, we look at a question that we've repeated from last year on deep learning, where we're asking about when will capabilities based on deep learning become a competitive advantage for any step in the mask making process. And when you look at this year's results on the bottom, in gold, you see that 22% indicate that the year would be by 2022, versus last year when 62% had predicted the year 2022. So when we see this kind of shift in the results, we know that the predictions are certainly less certain. Now let's turn to a question that we've asked over the last 5 years, and we can compare the results. So this year we found that 95% say ILT is in use today, and that's compared to 84% who said that last year. Now let's look at some of the details you can see in the chart. So first on the far right, obviously, then only 5% indicated that no layers use ILT this year. Now, when we look at the details circled, this is where we see the pattern of growth around the response of some critical layers of leading edge nodes use ILT, with this year's response being the highest at 41%. Now, this question was specifically about ILT in general. Now let's turn to our new questions that pertain to curvilinear ILT masks. Now, the first two questions were very similar, and it led to a somewhat complicated chart. So let me explain. What we were looking for in having two very similar questions was whether there would be a difference in the trend between the responses for EUV and 193i, as well as whether there would be a different perspective on the highest extent to which curvilinear shapes would be used on mask versus the average. So when you look at the charts, what we can see and conclude is that there is a pattern of difference for 193i and EUV, but the pattern of difference is not distinguishable between the highest percentage and average percentage. So in the chart on the left, you can see that the participants said 69% of them said that 193i would use at least 20% curvilinear shapes on any given mask, whereas only 47% indicate that for EUV, and that the pattern continued when asked the question about the average percentage, with 60%, the higher percentage, saying 193i masks would have curvilinear shapes versus 39% on average for EUV. Now let's look at some of the top concerns in making curvilinear masks. And this is a similar question, and thus the chart looks similar to our multi-beam mask writing question. So what we've done, again, is each box represents a concern in this case, and the height of the box represents the average response, with one then being the biggest concern, and the plot of the individual responses are inside the box. Since this is the first year we've asked the question, you don't see the blue shading. So in the number one ranked reason, we find mask inspection, followed closely by the number two reason of mask shop software infrastructure, including data volume, mask data prep, MPC, or verification. The third and fourth reasons are closely ranked as access to multi-beam mask writers and ILT software. And then in the fifth and sixth positions are mask metrology and mask repair. We wanted to go on and further understand how important are these concerns? How big concerns are they? So what we found in then asking for agreement to one of these statements, we see in the top result that only 4% believe that concerns are insurmountable for now. And 71% believe that leading edge mask shops can handle at least a limited number of curvilinear masks by the year 2022. So with that, let's conclude by reflecting on how the luminaries are very positive and optimistic in general. In particular, the sentiment increased and even grew stronger that mask revenue is increasing for 2021. The luminaries are also quite positive that the purchasing will increase over the next 3 years for lasers and BSB machines, while multi-beam purchasing will remain very high. And then finally, in a first attempt at getting a confidence in curvilinear mask making, the luminaries' confidence is very high in this. So with that, I'd like to just say thank you very much to all those who participated, again this year as well as over the past decade. And the results are available at ebeam.org. So for now, please stay safe, and we hope to see you in person next year. Thank you.
Thank you, Jan. I introduced to you earlier Tom Cecil, Chris Progler, and Mikael Wahlsten. So let's just go into the panel session to talk about these results.
We always ask about what's going on with the business of mask making every year. And in 2021, we are looking more forward, including the effects of COVID, could be negative, could be positive, right? In the case of semiconductor manufacturing. But as of July, when the survey was taken, it seemed like the luminaries were a lot more positive about 2021 on the right than they were last year about 2020. And so, Chris, as a mask maker, what do you think? Do you think do you agree with this finding? Do you think it's going to be looking good going forward, or and what do you think about the delta that happened since the July timeframe? So, do you think that's going to have a negative effect in this?
Yeah, I think in 2020, looking at this, there was probably a lot of apprehension. It was still relatively early in what the impact would be of the pandemic on the electronics industry. And as you know, masks generally follow the IC industry, maybe 1.5–2% of sales. It's been running that way for quite some time. So masks generally are going to follow the IC industry. But I think the optimism in the 2021 survey is well justified. There's a tremendous uptick in mask units and also ASP, probably for the first time since I've been working in masks, maybe 20 years. Prices are going up in masks, not necessarily only at the high end, but in mainstream nodes, mid-range nodes. And that's kind of a supply-demand issue for sure. The mask industry is supply constrained. So I think that is kind of giving people a lot more confidence to name these sort of up numbers. The other thing we're seeing on the mask side is more node migration in the mid-range nodes. So, for us, the real story in masks in 2021 and partially 20 is the strength in mid-range and the lack of capacity to serve that strength. So that's where we're seeing the biggest demand, the biggest upticks. So yeah, I think this is justified and it makes sense to us from a demand perspective. As far as Delta having a negative impact, to the extent it impacts consumer demand and that sort of stuff, that hurts, but at one time GDP and ICs were very heavily correlated, 95% we saw. If GDP was good, ICs went up. That's kind of broke down with COVID and the pandemic. So everybody knows GDP was negative last year globally, but IC was up about 8–9%. GDP should recover this year, 4 or 5%. The IC industry should be up about 20% or more. So that correlation is not as strong. So, to the extent Delta impacts global GDP in a negative way, maybe 1–2% negative, we don't see that having a correspondingly large impact on the semiconductor and hence mask supply chain. We're still pretty optimistic. If it goes longer than a year, that's a different story. But for the next 12 months, this looks pretty solid to us.
That's great. Thanks, Chris. Mikael, how are you seeing it from the supplier side?
Yeah, I think we also indeed enjoying quite good times, and we experience a really positive momentum now, driven by the I think current strong market that we see, but also there is a lot of very strong long-term forecast that we see. So we forecast it will be a strong market for several years, and we experience that our customer have really identified several business opportunities that new modern writers and other equipment can enable. So from our side, we see, I think, investments being driven by mainly three reasons. So either is that if you have a capacity expansion on the leading edge side, but also as Chris alluded to, we see a good interest for adding capacity on the more mature nodes also. So there is a good business opportunities also there. But at the third reason, we see also that our customer take advantage of the good market to make investment and then modernize the mask writer fleets. So yeah, for sure we also experience a good market now.
So you're seeing
good
a
market
good
sentiment
mood out there. Now, what about the FPD side? Mycronic, in addition to having restarted the photomask laser writing business a couple of years ago, and you've always been the mask maker for the FPD, flat panel displays, right? And how is the business on that side?
Yeah, I think on the FPD side, it is a little bit different story, because there during 2020, actually the photomask market for display took a kind of large hit, especially in the second half of the year, and the main reason for that was that the pandemic with work from home and the general kind of screen updates for entertainment and looking on Netflix and whatever you did at your home office or at the evenings, put a large demand on displays, and that created a shortage on the market. So that encouraged the suppliers, I would say naturally, to produce the models that they already developed. So they spent less time on developing new display models and did less R&D. So that hit the FPD market last year's. But now we actually see that the market and the demand is on the path to recover back to high healthy levels again. So, and also we know that there is a long-term trend towards higher display quality, larger TV sizes, and also the display is for sure growing, has a growing importance to be a product differentiator. So based on that, I think that the long-term positive outlook is positive, but the market dynamic on the FPD side was a little bit different compared to the semicon side, I would say. But
yeah, so that's great. So basically, leading edge and mid-range, like Chris was saying, and also for flat panel displays, and things are generally looking up. So it's not surprising that the next slide, which is not from the Luminary survey, it's from from SEMI, and shows pretty optimistic look for photomask sales. And to the left of these bars, we've been kind of stuck around $3 billion for the longest time, and then it started to break up onto the right, and it's looking pretty strong going forward. So overall, like the three of you, well, what do you think about $4.8 billion in 2022 is what SEMI is saying. So Mikael, what do you think? Would you take over, under, or about the same?
Yeah, I personally think there is a lot of investment going into the industry, and we see all markets picking up, and also Europe. So and also, as Chris mentioned, the pricing also on the mature nodes seems to be quite firm or even going up. So I think that will help to beat it, and it's a little bit abnormal behavior, as it has been historically. So I think that will help beating the forecast.
Yeah, in every segment, right? Yeah, Chris, what do you think?
Yeah, as I'm looking at this, I think as a percent of IC revenue, photomasks are not really going up much, right? It's about 1%. So if you look at this, 2020 ICs were 400 billion, maybe it went up a little bit. We used to run about almost 2% of IC revenue in photomasks. And so if some of the projections are correct, ICs hit 500 billion in 2021, that'd be about a 25% increase. The percent the industry is willing to spend on photomasks is actually shrinking from that view. So the top line's going up, but we are not getting an increased part of the share. I mean, that's one thing I would conclude from this, the relative growth of photomask versus IC. But with that said, yeah, I think, there's a pretty good chance, I agree with Mikael, to exceed this number. There are capacity constraints, so that's limiting the amount of output, but ASPs are up. So that's helping. The mid-range is quite strong. AMAT had interesting earnings. 50% of their equipment spend was in mid-range. I mean, I haven't seen that from AMAT in a long time. They expect that to double. So they gave a very bullish report on equipment spend in the mid-range. So that's a really healthy trend for masks, because ASPs are good. The masks tend to come out faster. They're a little easier to make. So, I think with those things, we can beat this. So I'm going to say a little bit over is probably a pretty good guess. And the other thing I guess I'd bring up here is, we've been talking about it at Photronics anyway for a while, the notion of differentiation through design or the resurgence of the ASIC model. That's for sure coming back. I mean, FPGA took a whack out of that 10, 12 years ago. I think that has passed. And we are seeing a lot more effort to differentiate through design, not hunting for just the killer app, but very, very broad use of ICs and more application-specific use of them. If you look at the top 10 categories, I think 7 of the fastest growth were either special purpose logic or application-specific logic. So that feeds a lot of mask units. And if you combine that with mid-range node migration, I'm hoping we can get to a point where masks start to outgrow semiconductor or claw back part of the spend that many other segments of the industry have enjoyed, because we've been shrinking as a percent of the total.
Thanks. Tom, what do you think? Over or under?
Well, I mean, for me, working a lot with the advanced customers, certainly see that the new scanners and like we talked about the Curvilinear and new multi-beam mask writers, a lot of that is certainly coming and growing. And I can imagine that there's going to be a lot of capital outlay there, and that maybe there will be a larger slice for Photomask to make sure to be able to use those machines well. But that may be coming in some future years. It's still arriving, and I'm not sure how much of that gets accounted for in 2021. But maybe if there's a lot of PPP money or something sitting around waiting to be used, we'll see it get spent this year.
Okay, sounds good. All right, let's go to the leading edge topic. Luminaries are pretty clear that the net of everything shift to EUV masks is really contributing positively to the overall mask market. Tom, you work on the IoT side, so I think you would know how it might be happening now versus in the future. In EUV, even though each mask, like the mask blank, is more expensive, the patterns that you print on the EUV today, I think probably are simpler, but they're probably going to get more complex over time. Can you, for the audience, give a little primer on how the different types of OPC or IoT changes the complexity on the mask?
Yeah, I think that's exactly right. I think similar to when other scanners have been introduced in the past, the first thing they'll try to do is really simplify any sort of RET corrections to as simple as possible. So we're talking about eliminating the use of any type of curvilinear or even assist features for the first masks that would come out in EUV. And now they will start adding some simple assist features. And then potentially, as these new multi-beam mask writers are coming out, which are more capable, there's some opportunity to actually do some kind of hybrid masks where part of the mask may be curvilinear and some part may be rectilinear, to just, that's gonna, for a multi-beam writer, that will cost the same because they don't really care which part is curvilinear or not. But for the OPC and inspection and everything else, all that processing, it's easier to have some, and the data volume especially, it's easier to have some parts being rectangular. So they will try to use in the best way they can some gradual introduction in the most important places of the more advanced OPC techniques.
Yeah, thanks. Yeah, so you see it getting more complex over time, right?
And unless the scanner can make another jump to get higher resolution, it just naturally comes to the mask solvers and shapes to sort of squeeze out whatever juice it can from the existing hardware.
Yeah. So Chris, what does that mean for the cost of the masks? And is it true that more complex shapes on the masks are more expensive masks, or is that just data processing and it doesn't make any difference?
Yeah, I mean, generally, I think that trend is true. It used to be a lot of it was driven by write time. So, the writer is a very expensive tool. The longer the mask sits on it due to depreciation costs, the more goes into the manufacturing cost, obviously. For multi-beam, I think it's helped that problem a lot. So you don't see as much of a depreciation cost impact due to long write times that you saw with vector tools. On the other hand, with complexity definitely comes more challenging manufacturing conditions. The tools generally are more expensive. Inspection tools cost more. The repair equipment, everything, it costs a little bit more on the equipment side. And complexity also tends to drive yield in the wrong direction for mask making. It has to do with dispositioning, defectivity, all of those things. So you get a negative impact often on more complex masks and yield, first pass yield, regular yield, and then hence cycle time. The thing that makes EUV kind of special is it's one of the mask technologies where materials costs now drive a disproportionately large amount of the manufacturing costs. So blanks, pods, pellicles, everything, that could well go up over 50, 60% of the build cost of an EUV mask. So here, when complexity drives negative yield on the mask side, that has a very, very large impact on manufacturing cost. Mm-hmm. So the prices will need to go up dramatically to compensate for that. So the only thing I would watch on this, nice to have ASP increases on mass products, but it has to be for the right reasons. And if the reason here is because yield is suffering, that is not a good reason for costs for ASPs to go up, because it's a productivity and performance issue for the mask maker and the user. So yeah, they will get more expensive. I'd like to see them get more expensive because they're bringing additional value, not because there's a big yield detraction.
So you're saying that traditionally mask write times were the dominating factor, but these days it's more than that. EUV masks are mostly written with multi-beam, and despite that, you think the mask costs overall are going to go up, even though the write time is the same, and complex shapes are still going to bring EUV masks to be more expensive.
Yes, yeah, I believe so. And again, it's tied into yield and productivity reasons that the complexity brings. It's not just accumulating that depreciation cost sitting on the writer. That's less of a problem here with the onset of multi-beam. So
right, okay. Yeah, thanks. Let's move on to other topics on EUV. We also asked the luminaries about what's happening with pellicles. A pellicle is the little cover that protects the surface of EUV from being contaminated. But EUV pellicles are hard because EUV is such a strong beam. What do you think is happening here, Chris? Maybe you can give a little insight into how it is that people are doing EUV projection without pellicles available until what the luminaries say is 2023. And what are they doing today to make it work?
Yeah, it's a good question, an interesting one. So for sure, EUV is being used. I can maybe put it into a few categories. One is, I think, despite that EUV's in so-called volume production, I think it's still running in some kind of quasi-engineering mode, even at the biggest chip makers. I don't think, if you looked at HVM from an EUV lithography perspective, it looks today like HVM in 193. It is a lot more hand-holding, multi-start masks, a lot more inspections are embedded into the flow. And there's certainly not as many designs as well, so it's a little more manageable, it's a lot more cleans. So I think EUV, partially it's working because it's still in somewhat of an engineering kind of mode, even though it's in a limited number of chips anyway for mass production. The second thing is, I think there's a lot of work being done to minimize the effect of these fall-on particles on the mask. For example, we call it a sticky mask. Basically, it circulates through an EUV scanner and kind of picks up particles inside the tool. And I don't know, I can't really say, but let's just say our sales of that particular product have gone up dramatically. So I think that this is the kind of thing maybe we wouldn't sell any if there were pellicles. So I think it's a little window into the fact that, the users are doing a lot of things also to keep the environments much cleaner than they would have, which of course impacts productivity and other things. So I would say they're kind of muddling through today, obviously, and it's working. But I don't think EUV is running in the same sort of HVM hands-off mode that say we're accustomed to today for 193 lithography. As that evolves, pellicles are going to become more and more important and start to be a critical part of the picture.
Yeah, thanks. So on this chart here, the 2020 answer is on the top and 2021 answer is on the bottom, and it's pretty clear that the luminaries are know something about something that's going to happen in 2023. What do you know, and what do you think is happening here? Is something happening in 2023?
Yeah, I think 2023. I mean, I would agree with the assessment on this chart from what I understand about it. I think pellicles are being used now in some limited production. There's probably were a few thousand shipped 2020, 2021. I think that number goes up well over 10,000 in 2023. If you look at the productivity of the equipment being sold that puts the pellicles on, they can do a lot of capacity, and those tools are getting sold. So the industry is clearly gearing up to for much wider adoption of pellicles in EUV, with also a fairly hefty yield and repellicle rate that's going to be needed. That's you'd kind of expect with the relatively immature state of the pellicles. So all the numbers are kind of trending as far as pellicle ships, equipment capacity, and that sort of thing to suggest that industry is gearing up for this sort of adoption, and they're expecting to have to do a lot more repels, what we call repels and mask maintenance and recertifications as part of that pellicle adoption at this stage. So I think it's pretty reasonable. Yeah.
Yeah, great, thanks. So that leads to the next question, next slide on pellicles, on the inspection, because without pellicles, for sure, inspection is being relied on. There's lots of different kinds of inspection, right? So I think it's probably confusing for the audience. What happens, masks get inspected in the mask shop, they get inspected in the wafer shop, and you could get inspected by the traditional 193 light sources, or actinic, which means you use EUV to inspect EUV, or you could use eBeam, multi-beam to inspect masks, or you can print a wafer and inspect that with eBeam. So there's a whole bunch of different possibilities. Yeah. Can you explain what's going on? Like, how could it be worth investment?
So I could figure it out. No, I think so. Yeah, so the inspection is pretty confusing. I think I'll say for commercial mask maker and EUV, 193 inspection still will be a workhorse of looking at those masks. And then we see that kind of marrying with EUV actinic as really the best path forward. There's kind of a natural low pass filtering and things, and obviously a lot of it in 193, but also an EUV actinic that's makes the inspection, I think, more productive and usable as a mask making tool. As far as the E-beam, so the second piece, the mask maker using a high-speed E-beam system, I think it'd be very nice to have both. This is kind of an affordability question, but if we had to pick one, we would use 193 and EUV actinic for the primary inspection capability inside the mask operation. The one thing nice about a high-speed E-beam systems is a multi-beam SEM. Actually, I would almost prefer to see that deployed on the CD metrology side more than the just straight inspection side, because CD metrology is a big challenge. And, particularly talk about even ILT, some of the things we touched on earlier, everybody's very focused on how do you inspect those. But the metrology, the SEM metrology on those sorts of structures, if we really want to understand what's going on, the 2D shapes, contouring features, all that stuff, the situation with CD SEMs and mask making are really inadequate. So I wouldn't mind seeing that effort push more towards measurement as opposed to defect inspection on the SEM side of things. That would be, I think, a little more a little more valuable. Then in the wafer fabs, I think for sure they need to inspect wafers at very high resolution and high speed. Multi-beam inspection for the wafer fabs makes a lot of sense. In that case, it's more of a statistical sort of inspection step, unlike mask making. So I think that's where that fits in. You know, wafer high-speed inspection married to wafer prints to do what's clearly going to be a higher rate of mask validation in the fab for at least the next 3 or 4 years for EUV. That's where that piece of the inspection infrastructure fits in.
Good, thank you. It's a complicated subject, so thanks for bringing your expertise into that. Let's go to the next slide that talks about the turnaround time. Chris alluded to earlier, mask write time is perhaps the most dominant part of mask cost, but still other aspects are important. And turnaround time for EUV EUV masks is longer than 193i masks, and the perception is shifting a little bit, where people this year are thinking that it's more longer than they used to think a year ago. So I think there's maybe a general understanding of what's going on here. Tom, what do you think?
Well, I mean, for us, working with the customer to tape out a layer, it's a question of the total turnaround time for all the masks necessary to get that layer through. So even if you're doing double patterning on an I-93, you know, that could be faster. But if you have to do 2 or 3 of those, you know, then the overall time is really a question of how much longer is this longer bar. Let's just say it's 50% longer, 70% longer. That still may be better overall than running a double patterning. So it's, for us, it's hard to say a one-to-one comparison, because that's really apples and oranges when they're talking about the throughput for the layer and ultimately the fab's total turnaround, mass turnaround time to get an entire chip out. So it's a complex question there.
Yeah, so but you're the expert on IoT computation. Doesn't EUV, EUV being more precise or something, and doesn't that require like a finer grid to compute on or something?
Yes, definitely. Everything is smaller. If you take something that used to be double patterning and shrink it down, all the features are smaller. And the writing and inspection and MRC and all of the tolerances on the mask are a little bit tighter. So definitely you have to inspect and make sure you're within tighter tolerances. So as we talked earlier, the masks start becoming more curvilinear and having smaller shapes for EUV, and it will eventually be as complex of a mask as DUV. But it will be smaller. The total turnaround time for getting it through will definitely start increasing, and we'll have to use advanced techniques to handle all those things.
Mm-hmm. Yeah, smaller and more, right? Or is it because of SRAFs? Are they the same or something? Or like, is the shape count more for EUV or no?
On a per layer basis, the shape count will be, if it's curvilinear, it'll be as, again, like I'm saying, it's 2 to 1. So let's say you're comparing a double patterning on DUV versus an EUV. Those shapes on the EUV will definitely be smaller. The wavelength is smaller, all the granularity, all the low pass filter, loses less light there at the high wavelength. So everything will be smaller and denser. And need to be controlled to a finer tolerance.
Mm-hmm. Yeah, thanks. Chris, do you think that the industry in general is going to let things take longer, or buy more computers to make at the same time?
Yeah, well, I think the industry won't like to let things stay longer. And by the way, this is an interesting chart, and I really believe it. I think the mask industry is quite surprised at how difficult cycle time has been to deliver EUV masks, even with the faster write times. Surprised, I think, a lot of people, and it's using a very large amount of capacity in the captives. We see that directly because outsourcing generally has increased from the captive mask operations. And while I don't have proof, my belief is it's because they are consuming a lot of bandwidth trying to get EUV mask built. So I believe this, and I think it's an important chart. You know, EUV to really deliver on its promise, though, which is a cycle time. Generally, it's a simplicity, performance, cycle time cell, right? Technology. That's why it replaced quadruple patterning. These numbers have to get better, I think, for EUV to reach its full entitlement. But there are a lot of pieces in the flow that take longer. For example, blank inspection and mask inspection. You know, EUV mask really needs to be inspected on 6 sides now. The top, the pattern side, the back side, extremely important on EUV because of contamination, a whole bunch of issues. And then the sides of the mask, you know, you need to get inspected because there's flaking problems from the multi-layer, all kinds of things. So that's one step we've gone to incoming blank, relatively straightforward, to now a very, very complex process. So that has to get improved. The other where productivity, I think, is taking a big hit is repair. We don't really have the greatest inspection capability for EUV yet. Actinic is just kind of hitting the world now. And repair is tough. It's a multi-layer stack. It's delicate. You've got absorbers that are different. And so, and I mentioned earlier how important yield is in masks because the blanks are so expensive. People do not want to scrap masks. So the repair loop is taking a lot longer than it used to as well because the validation and feedback is weak. EUV aims, all that stuff. So these numbers, I think, are real, and they are a surprise and a problem. Eventually will become an impediment for EUV adoption. So I think they have to be worked out, this turnaround time for EUV masks.
But do you think people are willing to pay more to get that, or?
Well, I don't know. To some degree, you know, cycle time in mass tends to rule, I believe, of the cost, you know, specs and cycle time being the 3 things that always have this push and pull against each other. Generally, speed, people will take compromises on the other 2 in exchange for speed. It's just the nature of the mask making business. It's always late. So yeah, I think so. You know, I believe there's going to be, to solve problems that have a direct impact on turn time, I think the industry will be willing to make investments in that, yes.
But you demand your suppliers to make it cheaper, right?
Yeah, of course. Everybody has price down roadmap. Yeah.
Yeah, that makes sense. All right, so let's move on to other subjects and away from EUV a little bit. So this question is about writers, laser writers and VSP writers, and also multi-beam writers a little bit. So let's see, Tom, can you talk to the left, is it rightmost? Yeah, rightmost multi-beam writing part. And obviously, there's a big green 90% there. And is that coming from EUV and Curvilinear? And what do you think?
I mean, I don't own the fab, so I don't know exactly what their use is, but it's likely they will be the first places that they want to introduce Curvilinear. Those layers, they will apply the multi-beam mask writer. So some of that will be EUV. I think some of that potentially can be a DUV that they don't want to migrate to EUV. You know, it depends on what their hardware configuration is, you know, at their fab. Like Chris was saying earlier, he's seeing more demand from like mid-range fabs. Now, are those using Curvilinear? I don't know, but certainly we are seeing it started to be appetizing for not just the 1 or 2 most leading type of fabs to get into that area. Now, will they go out and buy a multi-beam writer? I don't know, but that's the kind of thing where they're going to have to look at their entire allocation of scanners and decide how to deploy the multi-beam writer and curvilinear to the best advantage. Yeah.
Right, for the mask writers, yeah. What do you think about EUV masks going curvilinear? You said earlier that some kind of a hybrid approach, hotspots for curvilinear for hotspots. Do you think like what's the reason to not use curvilinear everywhere if it makes no difference because you're using a multi-beam writer?
Ultimately, I think the fabs would like to use curvilinear everywhere if they have a multi-beam writer and it can handle it. The thing is, if the data volume is exploding too much, that's where they're going to be saying, "Hey, this is causing a choke point somewhere in the flow." There's a lot of tools that need to touch on that data, and that can be something that's an issue. So it would be great if somehow within the industry there can be maybe some more handshaking or partnerships between some of the maybe the ILT tools and the writer tools, or somewhere in there, to help alleviate the data volume issues, and then really be able to not have to worry about artificially constraining the resolution of the mask for the purpose of data volume control.
Yeah. Okay, that's great. So turnaround time does matter, and like Chris was saying, the industry has to solve this problem somehow.
What Tom mentioned, I'd like to elaborate a little bit on it. The other area on the mask piece that I think could enable more is the back end of the flow, inspection, repair. I think there would be more use of that technology if we could solve that. And the so-called repair with prints, you folks probably all remember it. This used to be a big effort many years ago in the mask industry, which is you have enough inspection capability and know-how that you only worry about repairing things that print or that are going to have a direct impact on the wafer. This is a big movement for a while. And even AMAT came out with an inspection tool called the ERA, which really did not catch on much in the mask industry. Lost out to kind of very, very high resolution, inspect every pixel, repair every dot. But if we could, at the same time we increase mask complexity, the industry could revisit a little bit a repair only what prints model, which means a very different way of approaching the back end in mask making. I think it's really enabling for this sort of thing, because that's where masks are getting stalled. The really complex masks are getting stalled out today. Maybe in the data side and data volumes, the writing goes pretty well, but the second place is the back end, is really understanding if that mask is going to work or not, what to fix, and what to leave.
The inspection and repair.
Inspection, repair, and metrology, multi-dimensional metrology. Yeah.
Oh, good. Thanks.
Yep.
Let's see. So staying with you, Chris, on what about the middle? Franklin Clark talked about this in this forum before. It's not all about the leading edge, right? You said that people needing to do EUV or multi-beam and EUV so much is giving you more business for the mid-range.
Yeah, I mentioned that a little bit. I think the captives are pretty overloaded. So if you look at like ASML, they have 85+% of the scanner market. So you can get a pretty good read what's being sold by just looking at their earnings reports. And EUV is strong, and deep UV is also very strong, KRF in particular. Some of that is due to just more non-critical layers and cutting edge designs. But what really has happened, as a few of us have discussed so far here, is there's a real resurgence in mid-range tape out and design activity. It's ASICs, it's much more pervasive use of ICs, particularly in Asia. China, the mid-range is really strong on the logic side. So that to me, as a commercial mask maker, if I were to be candid, which I am, that's a far more interesting growth story right now than EUV. The other challenge is there's really supply constraints on equipment there. A lot of the tools the industry used to build those are a little more on the mainstream, going end of life and end of service. To replace them with new tools that are a node or two ahead, more advanced, there's not economical, doesn't make sense from a cost perspective. So So yeah, that mid-range is a really interesting both equipment and technical problem to solve. You know, the early days of IMS, when I was actually on their board for a while, and then they were acquired, as you guys know. I really pushed to try to have a really high-speed, mid-range multi-beam mask writer. You know, something that can knock out, you know, 28 nanometer, 40 nanometer node mask in hour and a half. Be a very different tool than what we have today. That tool, you know, I'm totally speculating here. I'm sure they'd be selling as many or more of those today than they are of the cutting edge multi-beam tool, if it was commercially available.
Yeah, but it would have to be cheaper, though, right?
Yeah, of course, it's a different tool. It would be redesigned, have to be cheaper. Yeah, have to be different way to look at it. Yeah.
Interesting.
Well, the cost
business
of ownership has to be less. You know, you can handle some ASP on the equipment if the total cost of ownership, you know, is going in the right direction. It has to be faster and more productive and produce better quality output for yield reasons. Then, yeah, you can take a more expensive tool, because if the demand is there, it still makes economic sense.
That's an interesting idea. Okay, so let's talk about the laser mask writers. Mikael, you went back into the photomask laser writing business, and you must have done that because you saw an opportunity. And then I've been seeing a lot of press releases from you lately. So, like, how is that business going, and what do you see as the prospects?
Just a little bit background. So yeah, we together with our customers quite a few years back actually identified that this were likely an opportunity in the markets that was approaching here, so that we can address with our technology. So that initiated us to start a quite comprehensive development program a few years back, where we decided to develop a completely new platform, where we, as Chris mentioned, that we took into account really the ambition to create a new modern mask writer with focus on cost of ownership. So making sure that it was compatible of already installed machine or fully depreciated. So it should be a really attractive tool. And we decided to develop both an I-line and an EUV model because we saw that there will be demand for both technologies due to a little bit different reason. But we think that was a good, wise decision. And now we have sold 15 units, and we launched it end of 2019. So I think we have been really satisfied with the performance so far, and we see a good demand also going forward, and we have a good customer discussion. So we think this will continue in a positive direction. And just alluding a little bit to what you can produce on these writers. So the I-line you can probably push down to 130 nanometer and the DUV around 90 nanometer. But that being said, we will also have a quite ambitious roadmap around these machines. So for the future, we have the ambition to push this, I think, one node forward at least, both for the I-line and DUV. So I think there will be an interesting future for the SLX product that we have launched. And
sounds great. 15, you said, right? That's a lot.
Yeah, 15. Yeah, it's from a mask writer equipment company. 15 is a large number.
Yeah, it's a large number. Yeah. Okay, great.
I'll just support what Mikael just said, that, you know, I think Mycronics got into that at the right time. You know, good for them, recognize the need, and looks like it's they're executing well there. And there's definitely a need in this space. This is an area where there are a lot of mask units. As you know, the vast majority of mask units still produced by the industry are done on laser writers at nodes above 130 nanometer. In fact, there's no comparison in raw numbers. And there's a lot of design activity going on in those nodes, and there's kind of called micro node migration, you know, definitely nodes that have been static there for a while, even like 180. Folks are starting to try to squeeze a little more performance out of them. So it's a really interesting space now. for the equipment, the mass people, and I think the design community too, on trying to capitalize on opportunities.
Great. Yeah, thanks. Okay, let's switch gears now to talk about deep learning. It's an interesting subject. So, like, unlike the EUV pellicle question where 2023 didn't move from year to year, this one is clearly shifting to the right? Which basically says, well, it's going to happen, but 2 or 3 years from now, that's kind of and it's sliding every year. And what do you think is happening here? I know, Tom, you've given some important papers in this area, so I know that you've been working on it. And how do you feel about production deployment of deep learning technology and competitive advantage or disadvantage that you can gain in the mask making world?
So if you're counting the OPC or ILT as part of the mask making process, then certainly there is some pieces that maybe don't take the whole enchilada of give me the design and I'll give you the mask, and that's just one deep learning step right there. But individual parts of the modeling or some recognition of patterns or hotspots, these sort of more isolated or unique use cases are things that are definitely being done on the, let's say, RET or OPC ILT side. Now, as far as going into the mask making process, if we limit that to a little bit farther downstream, maybe there's some analogs as more image processing type steps or some kind of pattern recognition or other recognizing things that are somewhat done manually or take some real expert rule writing and these sort of things need to be done. Maybe if there's analogs that we can see from how deep learning is being used on the OPC ILT side, maybe we'll see that migrate into the mask making and inspection processes somewhere as things become harder or just smaller, or just the data volume becomes larger. Then I think the more image processing and modeling that needs to be done as part of the simulation for the mask making process, maybe we'll see some of those things start to be used. But I agree, these charts show people are not quite sure what to say in terms of when that will happen.
Well, what do you think about a competitive advantage or disadvantage caused by presence of deep learning as a part of in your field, or the MPC is kind of similar? So
yeah, I think it can be a big competitive advantage if you can get it to work. But the real question is, will the customers who have a tool where they felt like they understood all the equations and everything in it be able to migrate to something that's more of a black box, where they're not sure, okay, maybe in a week it's going to give me a really strange answer, and that's going to cause me to waste a lot of money on something, or make a big mistake, right? I think it's easy to get started and make progress with deep learning, but I don't think that we've seen that the real theoretical foundations are quite there, or the understanding where you can convince a customer to take a big runtime reduction in a risk and say, we're going to trust this black box that we don't completely understand. So I think that, but hopefully as time goes on and more math is developed and more experience is gotten with these type of tools, that it will just become more natural and take a burden off everybody.
So the big benefit you're saying is runtime reduction, and the fear is that the answer is right 100% of the time, which of course is required for mask making.
Mm-hmm. Yeah.
Yeah. Okay, that's good. Yeah, very good. Chris, what do you think from the consumer's point of view as a mask shop? Do you see that deep learning makes any difference in what you choose to buy? And do you see that deep learning content can differentiate merchant mask making offering to your customers?
Yeah, I mean, I think there's tremendous, I will say, untapped potential here. The mask industry on the manufacturing side really lags a lot of other parts of the semiconductor supply chain and implementing these sorts of things. It's a little bit the nature of the beast. I mean, still even automation, things that, wafer fabs have done 5, 7, 10 years ago, very little real automation and even basic machine learning going on in monitoring SPC and control limits and things like that and mask operations. Partly it's a limitation of the equipment supply base, partly it's a nature of the type of product, but there's tremendous untapped potential. But I agree with Tom, you've got to find the right first niche application and really demonstrate some measurable benefit to get the mask manufacturing side of people excited about it. To just market that, hey, there's a deep learning, embedded into this particular software suite or whatever it is, I think it's a pretty practical group of folks, and I don't think that's going to get a lot of attention. I mean, the one classic place people have been trying to do this is defect classification, so-called ADC, automated defect classification. Still a huge problem. We still get defects, and we have technicians staring at every one of them on an inspection tool screen, deciding if it's important, not important, should we repair, where did it come from, is this from an etcher, is it? It's highly manual, and ADC has been an area where this sort of technology could have a very big impact, but it proves to be quite difficult, actually, to implement. Standard kind of AI training things, we've actually tried them in our facilities, have not been effective. So a more sophisticated deep learning approach might allow us to crack that problem. And if it works there, then, I think you'd see an open-minded community. So, okay, well, we can insert it here as well. But, the mask industry lags in this. Even MPC, mass process correction, is only now being, I would say, fairly widely adopted. And it's relatively simple compared to OPC. And there's still a lot of reluctance, so I think we have to be pulled along in here, and that's going to come through collaborations and those sorts of things, and how to implement this technology in mask manufacturing.
Yeah. ADC, or defect categorization, seems like an ideal. It's image processing. It's protected by an operator that's actually going to review that result, right? I mean, seems perfect.
It's on all the things that Tom mentioned. It's manual, a lot of judgment. There's tons of data, because for sure we got lots of defects, and you could constantly learn. And but it is not. Anyway, yeah. So I think it's a great place to try to implement some of this.
Yeah, thanks. Hey, so Mikael, you have been doing a lot of deep learning. You've published a number of important papers in this area in quite innovative ways. Maybe you can tell us a little bit about your experience with deep learning.
As you said, we have explored deep learning for some time for different applications, but I think now we have moved on from more exploratory phase to implementation phase, at least for some applications. We long term we see, as you mentioned here, you see a number of applications where you probably can use this technology, or at least as an assist technology for assisting human design or human judgment. But what we target for the first application is to develop a deep learning based support tool that goes through a vast amount of data that our mask writers produce, and help both our customers and our service engineers to judge and monitor the tool and flag if there are any anomalies that happen during a write time. So a little bit alluding to the SPCs, kind of using deep learning to flag that now suddenly something happened. Please check this carefully, or check this area in the masks carefully. So that kind of support to the customers. We see some potential there, but we haven't a finished product yet. But we're at least going into the productification mode. So hopefully we can have the first product out there soon.
Yeah, so you're going into the production deployment mode right now with some of your early work, right?
But
So
it has taken us basically 3-4 years to kind of exploring and understanding the technology to get to this phase. So, as you said here, it takes time and it requires a lot of experience, and then really finding the right application, the right problems where you can benefit from deep learning. And as we see it from now, it's more like support. And as you said that, Thomas, there will be a reluctance and for this black box concept. So I think starting finding applications where it's not critical, for example, like monitoring and things like that. So it's not directly into the design, because it's always a little bit scary, don't understanding what could go wrong with it. So
Yeah, so construction things might be scary, but inspection things might be a good example, just like Chris said, right? Yeah. Okay, that sounds great. Yeah, thank you, and good luck to your productization efforts.
Thank you.
Yeah, let's move on to curvilinear shapes. We actually talked about it throughout the session, but maybe Tom, you can summarize again what we're looking at here, and the difference in curvilinear deployment between 193i and EUV.
Yeah, so it certainly looks like on the high end for a given mask set, I guess this is about a particular mask set, it looks like they're expecting that EUV and 193 certainly have a chance to have some high between 80 and 100% of curvilinear shapes on that, which is certainly going to be higher than the average. I think this trend probably will follow along the capabilities that we've been talking about in this panel discussion the whole time, especially the introduction of the multi-beam writers. So if purchasing of those writers goes up, like you said before, what's the reason not to use curvilinear? And if we can get the data volume under control, or we have some hybrid mask where the data volume is sort of artificially controlled, but we try to squeeze out what we can from the curvilinear part of the mask that's the most important, then these will definitely start becoming more blue. And it's interesting also what Chris said, it's not happened yet, but maybe the multi-beam writing companies will follow sort of the Tesla model. The Roadster comes out, which is super capable and advanced for the most advanced node, but then there's something made by having some kind of a mid-range tool, because ultimately that's where the extreme majority of masks are getting made anyways. So if some of the leading fabs can feel comfortable with the multi-beam writers and curvilinear masks, maybe they can backfill and get higher yield on some previous layers, or maybe there's the mid-range people that can start adopting a more advanced style of mask and mask writer if they feel that the price is a little bit more under control for them.
Okay, let's go to the last one, continuation on curvilinear. Actually, Chris touched on this a little bit before, but what then are the barriers to curvilinear masks is the question, right? So if you have a multi-beam writer, then you can do it. But what else is going to prevent curvilinear masks from being the way you write masks in the future? What do you think, Tom?
Well, certainly if I compare this to the kind of charts they probably had for the last 20 years on how are we going to get EUV into production, this looks more positive. Especially on the right there, they can handle limited number of masks. And as the software in the ecosystem starts getting used to things and people start innovating, and maybe they add something for like, look at the thing that Chris mentioned about the automatic inspection. Maybe that's an area where there's actually some room for innovation to sort of knock off one of the areas there. And then for the infrastructure on data volume, there's got to be ways that the OPC ILT companies can somehow reduce the volume or work with the downstream tools to partner up and get some kind of way that to streamline the process. So I think there's probably solutions if it's important to get more masks through, and there's probably some untapped. This is a new area, right? So there's probably techniques maybe coming from the upstream tools that could be eventually migrated to some of these other areas to help solve some computational burdens.
Yeah, thank you. Chris, what do you think?
Yeah, I think I'd probably, just reiterate what I said previously. I think the pattern inspection, dispositioning, repair, that's, I think, an area that would need to be addressed for wider spread adoption. Otherwise, there's a chance it could look like the 193 trend, even though there's, the writing time issue is, at least the time on writer has been improved a lot. Still, there are other things that are going to prevent wide-scale adoption. So, a small but very important tool in the toolbox for lithography ecosystem versus something where you start to get an appreciable fraction of designs that can benefit from curvilinear masks. I think the back-end issues, at least as a mask making side, have to get addressed. And that would mean migrating more to image-based characterization and disposition as opposed to, let's call it, discrete pattern characterization and disposition. So that I think is an interesting area to look at for wider adoption here.
But you're agreeing with the luminaries in general that a limited number is okay, but you're saying for widespread adoption, these things need to be addressed.
Yeah, a limited number is manageable. I think even today. Yeah, sure.
Yeah. Okay, great. So thank you very much. So just to close, how are you feeling about the mask industry overall? Thumbs up, thumbs down, sideways? What do you think? Okay, very good. All right, thank you very much. All right, see you next time.
Yeah, thank you. Bye.